Hello, welcome to Introduction to IBM SPSS Modeler 18.2. This is part one of a three-part series. Part one will cover extraction, transformation, and loading, also known as ETL, or data shaping, or data wrangling. There are three modules in part one, but today module one will deal with running Modeler and connecting data sources. So as I said, this is a three-part Modeler training series. First being extraction, transformation, and loading, where we have three modules. Second part is part two, exploratory data analysis, learning to understand the data that we have, do some preliminary analysis before we move into advanced analysis or predictive analytics. Part three will cover introduction to predictive analytics. My name is Chris Engstrom. I'm the Director of Advanced Analytics and Machine Learning at eCapital Advisors. eCapital is a technology consulting firm based in Minneapolis. My background, I studied economics and was lucky enough to have a work-study job building models and doing statistics in college. I worked in the direct marketing industry right out of college, building models in the early 90s. Spent 8 years at Microsoft in various quantitative roles in the 90s and early 2000s. Moved back to Minneapolis. I love technology, so I started working for, I think, the world's largest medical device company called Medtronic. Was there for 8 years. My last job there was Director of Analytics in the cardiac rhythm disease management area. I then consulted analytics and predictive modeling on my own for 4 years and spent a year at a medtech startup before I came to eCapital to help build out their data science practice. So before we get to Modeler, I just want to go over some general trends that are important for you to know, but also relevant to this series of Modeler 18.2. And what we now know, and certainly in the last 10 years, data have become strategic assets. The amount of data and the cost of storing, amount of data has increased and the cost of storing data has decreased. And what has also happened in general is, like, technology has just become so pervasive in our lives now. If we think about just the last 10 years in terms of what's become available, even just on our mobile devices. But technology is becoming much more pervasive in our communication devices, our television, our internet habits, our cars. And so with that, data science is becoming pervasive in our lives as well. And I've been practicing data science since the early 90s, and I've been waiting, for a long time to become more mainstream. But what I can tell you, these last 2 years, data science is really gaining traction. It's happening now, and it's happening fast, especially with embedded machine learning and decision optimization applications that are being embedded in software, in our phones, in our cars, and so on. And as consultants, we start to see kind of how companies are reacting to these macro trends in technology, and what we're seeing is that organizations are changing and starting to adjust their organization and functional areas to kind of accommodate these inevitable technology trends. But at the same time, we can definitely see a data science gap developing. And so over the next 5 years, and certainly over the next 10 years, what we're seeing is companies who are adopting predictive analytics, decision optimization, data science, advanced analytics, they will start to get a foothold and be part of this gap in data science haves and have-nots. Essentially, these tools are basically to bring a competitive advantage. We use these tools to increase an organization's effectiveness or efficiency. And at some point, it will just become table stakes to compete, to have a proactive plan around these methods. And the earlier adopters and those who are taking kind of a proactive plan to planning out these methods, as opposed to just reacting to them, those companies will stand to marginalize their competitors. However, now we've seen a lot of companies, seen a lot of hype around this area, but data science ROI is a serious challenge. In fact, a very small portion of data science projects are actually deployed these days. So ROI has been a big challenge, but when when a handful, and this has been researched, but when a very few handful of companies are getting traction with it, that will further drive the data science gap, because as they get traction, prove ROI, they're going to invest more in these capabilities, and they'll further distance themselves from those organizations that just aren't investing in it at all or don't have a proactive plan. However, relevant to this training series, there is a self-service machine learning trend, as well as an auto machine learning trend in open source, that will actually likely solve this problem with the help of very powerful tools like SPSS Modeler. As consultants, we're always trying to look at what are the fast growth waves. And if we think about the last 10 years, there's been a fast growth wave in what was called self-service analytics. What this meant was there were analysts in companies who were kind of frustrated with having to go through IT for every single piece of data, and they were kind of doing an end run around IT to say, just go to a data source owner, say, give me the data, just dump it in Excel. And they've been putting it in very powerful analytics tools over the last 10 years and really gaining traction in terms of making business decisions with these new analytics and BI tools. But what we're seeing now with tools like Modeler, and Modeler's been around for a long time, but with tools like Modeler, now it's exposing these same analysts and to very much more powerful tools that allow them to do much more advanced analytics, predictive analytics, and various other data science approaches. And so we think in the next 5 years we're going to start to see this self-service machine learning wave as the same analysts kind of start adopting these amazing tools and start doing much more with them. And what that means is, so the question is, why use IBM SPSS Modeler? And what is it to start? Basically, it's a visual predictive analytics data science tool that uses a workbench workspace where you drag nodes and create these streams and data flows on the workbench, and then you can save them, and they can be very powerful. But the key here is that there are many stories of companies that have hired data scientists and then just kind of given them all the data they need, to make applications and solutions, and they've failed miserably, namely because you can't just give data scientists data and expect to have an ROI measured, business impact. It's more rare than common, and so the belief here, and this is what's contributing to this ROI challenge, and the lack of successful deployment of data science projects. But the key here we see is the analysts in organizations, such marketing analysts, finance analysts, business analysts, operations analysts. These are people that are sitting in a rare position because they already know the data and they understand the business domain. So utilizing tools like Modeler is a very powerful proposition for an organization, because these analysts can start to connect the hardcore data science folks with the decision makers who the analysts are already working with on a daily basis. So I think it's a great time to be an analyst, and part of that comes from tools like Modeler. At the same time, Modeler allows and can enable an analytics culture and discipline by providing common frameworks, the ability to annotate these streams, and it's a great way to standardize analyst work for effortless sharing, review, and documentation. It creates, in other words, when people work with spreadsheets, they work in a very custom way. So if you build a very complex analysis in a spreadsheet and you hand it over to another analyst to review it, you can't just hand it to them. You'd have to sit down with them to show them exactly what you did, and that can be a challenge. But with Modeler, the stream is very self-explanatory, plus you can annotate it. So you can pass streams between analysts, and they can very quickly on their own figure out what you did in the stream, and then give you a peer review on it, or add to it, or reuse it, or whatever it may be. And spreadsheets are terrific, powerful tools, but they just don't scale well for real collaborative analytics culture and discipline. Okay, and lastly, before we move on to Modeler, I just want to mention this slide, and this is a very important slide. So we have all these data from many different sources that we can analyze and integrate and so on. But the idea is that, you know, when we look at data, we analyze data, we're looking for variance in the data. Variance, but much more than that, we're actually looking for useful variance. Just finding variance and doing a neat analysis that we can't act on, that's like nice to know information, but it doesn't cut it when it comes to, you know, driving, you know, informed business decisions. So we're really focused on, and then at eCapital, we really focus on looking for useful variance. Useful meaning we can help it make our businesses more effective or more efficient. And the idea is that using a tool like Modeler, analysts can start to work together to ask questions, discuss ideas, analyses, predictive model options, and come up with ideas to then, you know, do real analysis and produce models and output that can, you know, really enable informed business action. So this is why we use these tools. This is why we're analysts. Analysts are critical thinkers, and they need the tools because they understand the business and they understand the data, and they're well placed to do this. Okay, let's switch over to Modeler. Okay, when you open up Modeler, this is what you see. What we have here is, this is what I call a workbench. It could be a palette, whatever it is, but this is where we build our streams and flows. Up here we see familiar menus in applications: file, edit, insert, view, tools, and so on. Then we have these kind of quick links that we can use, and as we go through the training, you'll learn to use more of these. But you know, here's create a new stream, and I'll show you how we'll do that. Open an existing stream, save, and undo, redo, and so on. Over here we have a window where we look for outputs. So we start with our streams, and as we add streams, they'll show up here with our outputs. As we run tables, run output, run graphical output, those will all appear here, and we can access them very quickly. And then as we start to build models, we can see those here. Here's the CRISP DM window. So CRISP DM was essentially a data mining or data science framework that was developed in the 90s. And what it does is it provides a very nice kind of framework for project development, where you start with business understanding, data understanding, and so on. And it's a nice way to organize your project work in Modeler. And as I'll go through these modules, we'll talk about, you know, using naming conventions, annotating your streams, using things like, you know, this CRISP framework can really enhance the productivity of your analytics collaboration the more of this standardization you perform, file names, file standards, the more powerful it is as you share analysis and output between analysts. Moving down here, we have the main tabs that contain the nodes. Okay, so what we have is tabs, you know, the source tabs where we go and get source data, record operations tabs. We'll go through these in detail, but we have field operation tab, graphical output tab, the modeling tab, output, you know, after we do analysis, create, you know, we wrangle data, shape the data into a new form, we can then output it, and then we can export it back to any place on the network where we store data. And then what we have, we'll go back to the source node to start, but what we have is, these are nodes, and what we do is we drag nodes onto the canvas and we start connecting them to create our stream. And so real quickly, so, you know, source nodes is where we go and get data to work with. We could go to a SQL database, CSV files, fixed files, go to a Cognos Analytics or TM1 import server, Excel files, XML, JSON files. I mean, all these popular data sources we can connect to with Modeler. If we look at record ops, you should see, if you've done work in spreadsheets or in SQL, you start to see some familiar things like select, sample, sort, distinct, aggregate, merge, append, and so on. So this is ways of kind of shaping data, working with it, integrating it. Field ops, again, this is very self-explanatory. It's filtering fields out, deriving new fields, imputing or replacing values in fields, reclassifying, binning values, and so on. Very powerful tab. Graphs is for essentially creating graphical output. Modeler has an extensive library or choice of visualizations to use. Modeling, which kind of is the heart and soul of Modeler, has all sorts of the latest algorithms with regard to regression, classification, clustering, neural networks, and so on. Very extensive list of algorithms. Output is, once we've done analysis, once we've done data shaping, we can create output, and we'll go through, creating spreadsheet, tabular output, crosstabs, data audits, statistical output, and so on. And then export is, once we've created output or an output data set, we can then export the shape data, the change data, or the output, or the model scores. We can export that right out to any source we would like, back out onto the network or on our machine, wherever we're storing data. Okay, so let's get started in building a stream. We'll just highlight these 3 nodes and delete those. So when we open Modeler, it just created a blank stream for us, which we'll use and we'll save later. But what we want to start, we always start with finding data sources. So we're actually going to start with 4 fields, 4 sources. First, there are 3 CSV files, and what we're going to do is we're going to append data together for this module 1. So we have 3 CSV files and 1 Excel file. And so we'll drag them onto the canvas, and then we'll go to this first CSV source node, and we'll right-click on it and say Edit. And it'll open up a dialog box for us, and we look for this file, and we just click here. And then we're going to go to our location where we want to find our data source, module 1, and we'll grab our first CSV file. Say Open. It gives us a quick view of the data set. Everything looks pretty good there. We can hit Apply and then OK. And so it kind of populates the name for us. And then we're going to connect the other ones. File, Open, CSV2, Apply, Edit, CSV3, Apply, okay. And then the last one is an Excel source node, so we're going to find an Excel file, import file here, there's our Excel file. And there we go. Okay, so we've dragged our 4 source nodes. We've identified the data sources, and now what we can do is just take a quick peek, and we can go down to this Output tab and just grab a table node here and drag it up, and then we're going to connect it. Right-click, Connect, and so now you can see we're kind of now creating a stream on the canvas. And so what we can do now is we're saying here's a data source node, here's an output node. We're going to connect, and we're going to right-click, and we're going to run this. So we can just take a peek at this data source. And as you can see, it's plowing through a number of records. I think this first CSV file has about 2 million records. And this gives us kind of this feedback, that this is running. Here's the elapsed time on this. And now our table's complete. And we can look at it. And so the table node really produces kind of this tabular spreadsheet output format. So here we have a customer ID, which is a unique identifier, date, order number, contract month, SKU, unit sales, store ID, state. Then it looks like product category, major and minor. And so that gives us our kind of tabular output just to check. And we do this all along as we build streams. We're constantly kind of taking a peek at what we're building, new variables we've created. The output, or the table output node, allows you to kind of quick view the data. So you'd say, okay. Okay, so now we've kind of connected some data sources. We've looked at our data a little bit here. But now what we want to do is all these data sources, it's the same data. We need to append it all together to create one file for analysis. So what we're going to do is we're going to go to the Record Ops tab here because we want to append, and we're going to grab this append node and we'll drag it up here, and then we'll connect our data sources. Right click, connect, right click, connect, right click, connect. Okay, so then we can right click on the append node, say edit, and what it shows us is it shows us the different fields, and when we're appending, all the fields must be the same, as you know. And so it shows us our 4 files, and yes, we can look, all the fields are the same, so we're going to hit apply. Okay, and then we want to look at that output. So we go back to output, grab a table node, connect it, and run it. So in this case, to review, we have multiple sources that people have given us. It contains transactional data that we want to append into a single file. And as you can see, it's plowing through quite a few records. It's going to go to, I think, about 3 million. Last fall, a client gave me, I think it was like 45 different files that contained 89 million records. And I was able to load these data very quickly in Modeler. So, and this is running on, you know, just a basic laptop. So Modeler can definitely handle large numbers of records. So what we have here is our output, and you know, all our fields are the same, but we can, you know, we can take a look at our output and very quickly get a visual. Everything looks good. There should be about 3 million records here. Yeah, so we can see that it's appended these 4 data sources together into a single file. And but now we notice, oh, sales, you know, we want the cents to show in the sales field, so we're gonna look at something here. So we'll say okay to this. We'll move this out of the way. So we can now drag a type node onto our canvas. So we go to field ops and find the type node. And the type node is one of the most commonly used nodes in Modeler, because what it does is it tells Modeler the types of fields that it's working with, so it can conduct proper analysis and calculations on those fields. And so we would connect it to our stream, open it up, and what it does is it shows us here are the fields in our appended file. And what we can do is we can decide, you know, what types that we want these fields to be. Now, a customer ID field is just a unique ID or a primary key. It's not something we perform analysis on. So what we can do is we can actually choose the type that we want to tell Modeler this field is. And in this case, it's called a typeless field because we don't analyze it. Date is a form of a continuous field. Order number, again, that's just an ID field, and that's a typeless field. Contract month, this is how old the current contract is with a customer, continuous variable. SKU, another typeless field because it's an ID for a product. And then units and sales, those are continuous. Store ID, again, a typeless. And then there are types of variables that have discrete values, like state, right? There's 50 plus discrete values in the state field, 50 states plus some territories. But in the case, what they call categorical or nominal, in the case of categorical, it's when you've just a handful of discrete values, but with state, we have quite a few, and so we'll call that nominal. And then with our major product categories and minor project categories, those have a vast number of discrete values, so we'll also call those nominal. Now, we also want to change, so the sales field shows 2 decimal places. So we can then go to the Format tab and go to the Sales and click on the Format. We can just double click right on that and specify that we want to see 2 decimal places. We can say OK, go back here, and then what we're going to do is we're going to tell Modeler to read these fields. And what this is called instantiating the type node, which is essentially, as you can see, it's pulling the data through the stream into the type node, where it's instantiating it with these types that we've identified. And it's plowing through all 3 million records here. So it says OK, and we say apply, and then OK. And what we could do is now take a peek, go down to the Output tab, grab another table, connect, and we want to make sure that our sales field run. We want to make sure our sales field has the 2 decimal places showing that we were looking for. So here's our dialog box. It says it's running. We just reached about 3 million. So here's our new table. And as we can see now, our sales field is showing the 2 decimal places in the sales field. So now we've kind of accomplished our task here. We've brought in these source files. We've appended them into a single file. We've told Modeler what these fields are all about and how we want to use them. And now we've kind of verified that our append worked well. And now we want to export this file out to some other location on the network. And we could put it in a SQL file, a flat file, an Excel file. We could export it to a TM1 server or various other data export to these data source types anywhere on the network. But what we're going to do is we're actually going to just create a CSV file. So we'll connect our stream. We'll right-click on this. It defaults to a comma CSV file, and we're going to call this. We'll go back out to our folder where we've been working, data sets, M1, and we're going to call this M1 append. Oops, there we go. M1 append save. We would apply that, and then we can just run that from here if we like. And so what it's doing, it's processing the 3 million records and writing it to a file, at the location of our choice. Okay, so this is wrapping up here. So now it's exported our appended table back out to a data source of our choice. And we can just get rid of these. These are just for demonstration. So now we've kind of completed our task. And but what we can do, as we build streams for projects, they can get rather complicated and long. And so what we can do is, I want to show you this last thing, which is the super node option. And so what we can do is actually highlight these nodes, and then right-click on any of the highlighted nodes and say create super node. And what it does is it collapses those nodes down into what's called a super node, and we can right-click on it and zoom into it and go inside the super node to see the stream that we've just created. We can then right-click on the workspace and say zoom out, and then we can rename our super node by right-clicking on it and say rename, and we're just going to call it M1 append. Apply that and say OK. So now we've created a super node that's kind of tidied up our workspace. Lastly, we're going to save our stream. So we'll go up to File, Save Stream As. We're in our M1 folder. We actually created a streams folder, so we're going to go there and just save it as M1 append. So that saved our stream. Okay, let's wrap up. Okay, so this was Module 1, Running Modeler and Connecting Data Sources. Today we covered a number of nodes. We covered the source node, the table node, the append node, the type node, the export node, and super nodes. And as we go through more of these modules, we'll start collecting more of these nodes. But next, Module 2 will be moving on to record operations. Thank you.